All right, PEC Safeland Module 3, Basic Orientation. We're going into one of my favorite modules. I think it really gets into the meat of what a safety program should be. So if you're in a position where you're going to be assisting in the safety program, this might be a good time for you to take some extra notes in your student handbook and maybe apply them when you get back to your specific area. All right, emergency action plans. These emergency action plans that we're talking about for organizations, and there's a picture of a 3-ring binder right there, deal with, what your company is going to do in the face of an emergency. OSHA requires that these plans must be written for any group that has more than 10 employees. It can be verbally expressed to anything less than 10. If you've got 5 employees, you can tell them, what you're going to do and ensure that they understand. But for most of us, having more than 10 employees in a group, we're going to have these written emergency plans, and they tell us what we're going to do in the event of everything from fire to explosion to terrorist attack, aliens landing on your front lawn, whatever you can think of should be in your emergency action plan. It lets you know where you fit in. What is your role in your company's emergency action plan? The idea is to develop a mental muscle management so that you know what you're going to do and how you're going to do it. A lot of really strong safety programs have drills. You can remember when you were in high school and grade school, the fire drills that we used to practice, we did probably one a month, where we'd either go crouch in the hallway or leave the building and go to the flagpole and do roll call. These are all in an effort to develop a mental plan so everybody knew in the face of an emergency just what to do naturally. I can tell you as a paramedic with years of experience that in most cases a lot of people, because they're not expecting to see what happens in a real emergency situation, freeze up. And if you've got this mental plan already burned into their brain, they'll just respond naturally. And that's why these groups like schools run these fire drills, so that when the fire alarm goes off, the kids don't question what they're doing. They just get up, form the line, and leave the building. And that's the idea of having an emergency action plan in writing, is to mentally prepare everybody for what they should do and how to do it. You need to know your job. If you have an assigned escape route that's yours, it's escape route A. You don't want to run to escape route B unless there's something blocking escape route A. It's, again, muscle memory on those kind of things. The emergency action plans would also tell how to report the emergencies. Let's just use for an example, somebody on your location, God forbid, has a heart attack. Who would you be the first one you would call? Well, if you would call the safety man or your company owner, you'd be wrong. In emergency action plan, in a situation where their life and limb is threatened, the first people to call would be 911. Now, your secondary phone call may be to the safety department or your owner, but primarily you want to protect the safety and integrity of the worker's health, so you would dial 911. All these things should be in your safety program. I've actually been on calls where we were the second call for an emergency in an oil field location because they called their owner to ask what to do, and which each time, thank God, the owner literally said, "Get off the phone and call 911. I'll call you back later." And then he made his way to the location. But all these things should be recorded in your emergency action plan, and it tells who to do what and how to do it. It's very important that we have to do it. Your primary focus, and there's our workbook logo there, tells us something to write down. Your primary responsibility in any emergency is self-rescue. Think about all the airplane movies or the airplanes you've been on and the little safety briefing they give you at the beginning. And they tell us if the oxygen mask falls down from the ceiling, put it on yourself before you attempt to help somebody else. That means that if you become a victim by trying to help somebody first, then there's 2 victims. You have to make sure that you're in a position of safety before you can try to bring somebody else into that position of safety. The other thing is, don't try to position yourself or operate in a way that you're not trained. There was a movie some time back, I think it was Sandra Bullock and Melissa McCarthy, where they were police officers and this guy was choking on a pancake in this restaurant, and immediately Sandra Bullock's character grabs a knife and cuts a hole in his throat to try to get the pancake out, when all he needed was the Heimlich maneuver, and that removed the pancake. She operated in a way that she wasn't trained, and it was detrimental. I mean, it was meant for comic relief in the movie, but in reality, that would do little more than damage the person and get you in a lot of trouble. Basic first aid. Medical attention usually given immediately after the injury, so we have to identify, is this something we can do on location, or do we need people with additional training? We see right there, number 2, only respond to the level of training. I can't beat that into your head enough. If you've not been trained on some technique you've heard about or seen or read about on the internet, don't try it. You must be trained. Know who at your facility is trained in first aid and CPR, and make sure that at least one of those people is on location whenever you go out. The reason for that is being our locations are so remote that we have to know who can help until first aid gets there. A lot of times when you dial 911, there may be an extended wait time. It's not like when you call from home where you dial 911 and you hear the ambulances within 4 or 5 minutes or 8 minutes on the outside. It could be an hour before you see an ambulance. It could be longer. You could be told we have no ambulances available because we're a volunteer service and you're in a really, really remote area. So having that person identified can mean the difference in life and death in some of these situations. Next, you need to be familiar on your location where your eye wash stations are, where your first aid kit is, as well as how to get to them if somebody were to fall off the rig and become unconscious, what you're going to do. All these things are part of your basic first aid procedures. Your evacuation procedures. If you are in a building and you have to evacuate, it's never wise to use the elevator. Number one, you could get trapped in there if there's a power issue. Secondarily, you could be in a situation where too many people try to get on because they're scared. The staircase is always your best bet if you can get to the staircase and get out of the building. The other thing is smoke rises if there's a fire. You could be in an elevator just literally hotboxed in an elevator full of smoke, whereas if you're in a staircase, you're descending below the smoke trying to get away from the area, and the heat rises as well. If you have a situation where there's a fire and you don't know if it's behind the door or not, using the back of a bare hand, you can touch the doorknob. If it's hot, don't open the door. That means there's fire immediately on the outside of that door. If you're in the location in the middle in a remote area, say we're dealing with an area where H2S is involved, you have to remain what's called wind conscious. What wind conscious means is you know which way the wind is blowing, so you can determine which way you will evacuate that location. If you're going to evacuate a location, you always travel crosswind and then upwind past the release of that poisonous area. If you're in a situation where there's a active shooter, we have what's called shelter in place, which means you find the safest or the closest safe haven and you stay there until the all clear is given. Unfortunately, we're actually having to teach this even in our school systems now for shelter in place because of the way that the world is changing. Your emergency response plan in your building should be posted. It should show where it is at in relation to the exits and the fastest way that you can get out of the facility using different exits for the purposes that you need to. Once you're out, once you've escaped the emergency, there should be a point in which everybody gathers. That's called the assembly point. We like to use the word muster or muster point in the oil and gas industry. But we have to know where our assembly points are so that we can get to them and be counted. Otherwise, we may have rescuers going in there looking for you, not realizing you went out another way. All right, let's talk about fire safety. A lot of people think that that's going to be dealt with by the fire department, and to some degree that is true. However, you may need to self-rescue, so understanding some of the concepts of firefighting is important. We have what's called the tetrahedron, a fire tetrahedron. Basically, in the fire tetrahedron, which is the picture on your right, there are 4 things required for a fire to actually work. In other words, if you don't have heat, oxygen, fuel, and a sustained chemical reaction, you won't have a fire. And what firefighters do actually is to remove one of those 4 elements from a fire so that they can stop the actual chemical reaction that's sustained in creating the burn. If I can remove the fuel source, the fire goes out. If I can deplete the oxygen in the environment it's using, the fire goes out. If I can remove the heat from the fire, it goes into a smolder and it goes out. All these things are used so that we can suffocate a fire, get rid of a fire, or just shut it down at the incipient stage. So fires are classified based on the kind of fuel they need for the fire. And basically, what does it take to burn to keep them going? And we have what we call A, B, C, D, and K style fire extinguishers. That's their classification. An A fire extinguisher, classification A fire extinguisher, is for anything that will burn and turn to ash. So that's a great way to remember it. If it will turn to ash, a type A fire extinguisher will put it out. They have samples of paper, wood, and cloth for us there. Next is a class B fire extinguisher. Anything that would boil would be sufficient to use a class B fire extinguisher. Liquids and gases of any kind that boil we could use a Class B fire extinguisher on. A Class C fire is for electrical fires, and the way to remember that is any fire that has an electrical current running to create the fire source would be a Class C fire extinguisher because it's going to be related to electricity. Let's jump down to Class K. These are for kitchen fires, the grease and cooking oils. You usually see these as these big automatic systems in the commercial kitchens when you go to your favorite restaurant. Take a peek back there by the gentleman doing the cooking or the lady doing the cooking, and you'll see these big tanks that are hooked into the overhead vent, and if there's an uncontrolled fire, they come on automatically and they extinguish the fire. D is for some metals that will catch on fire when exposed to certain things, magnesium, titanium, potassium, all these kind of things. You know, I don't have a great acronym for the D being related to metal fire extinguishers, so if you'll excuse me for saying it this way, I just say damn metals. That's for fire extinguishers that will relate to specifically to metal. What we use in the oil and gas industry, and for the most part a lot of professional offices use, is a combination fire extinguisher that is ABC. It'll do any kind of combustible that would turn into ash, any liquid that would boil, or any current that would be there. We use those type of fire extinguishers. So if you look at your fire extinguishers, they should be an ABC combination fire extinguisher. Fire prevention stops a fire before it starts. That's the best way to put it out. Unless you're a trained professional in fighting fire, your idea is just to get out of the situation and stop a fire before it gets out of control. Know the fire potential hazards of your job. If you're in an area where there's an accumulation of dust and there's equipment throwing sparks, clearly you have a fire hazard and that needs to be dealt with. An inner office situation may have less hazards than an industrial setting in a shop. Here it is again, only respond to the level of training. If you're not a firefighter and equipped that day with firefighting equipment, don't try to fight a fire. Know who at your facility is trained to fight the fires, and if no one is trained, then you know the number to 911. Fire detection systems are the first line of defense in any fire protection program. They could be multiple different types of systems that let you know that there's a fire, from smoke detectors to carbon dioxide detectors. There's a litany of different kind of detectors, but the automatic sprinkler systems are considered the most dependable ways to fight a fire. In that they come on based on the heat that's elevated to their system. They deluge the fire. In other words, they wash the fire down, removing heat, suffocating the fire, breaking apart that fire tetrahedron. And the other thing is they don't stop, whereas a fire extinguisher will stop on you. If your company has fire extinguishers and they want you to use them, you're required by OSHA to have annual training actually firing a fire extinguisher. I'm surprised often when I teach classes, people fire a fire extinguisher thinking they'll do a whole lot more than what they will do, and not really understanding how the process works of making it fire. You have to be trained on determining whether the fire is capable of being stopped with your fire extinguisher. Do you have the right fire extinguisher? And is this an emergency situation, or can you take time to try to stop what's going on? Remember, the only way to put out a fire is to remove one of the parts of the fire tetrahedron. And here's some examples of what that means. Cooling and quenching. With the water, you would reduce the temperature of the fire's fuel. And we could go through each one of these, but quite literally, what we have to do is break apart that fire tetrahedron, remove one of those four things to stop that sustained chemical reaction. And at that point, we can ensure that the fire will not progress any further. Portable fire extinguishers should only be used at the incipient stage or beginning stage of a fire. If the fire is fully involved or engulfed in the area that you're in, that's not fire extinguisher, that's fire department. And that's you getting out of there and taking the fire extinguisher with you just for a means of escape. All fire extinguishers should be fully charged and visually inspected every month. A lot of companies miss this part. They have the state inspector come in and do their tags to make sure that the fire extinguisher is in good working order. But it's our responsibility to flip that tag over and monthly inspect our fire extinguisher, make sure that everything is in working order, that the little gauge is in the green line, that the pin is in position, that if we invert that fire extinguisher, we feel the actual components flop back and forth inside, they're not caked in there, and that must be signed off on monthly. Portable fire extinguishers, always use a portable fire extinguisher that is correct for the type of fire you're fighting. If you have a type A fire extinguisher, which is for anything that would burn and turn into ash, squirting a type C fire extinguisher will do little more than blow it around. So you have to have the right extinguisher for the right job. Fire extinguishers are classified using the NFPA classification system. Again, we talked about what the letters mean, and they should match up. Extinguishers, this is surprising to most people, have about an 8 to 15 second lifespan. Don't think that you're going to have 3 or 4 minutes to fight a fire. You have 1 or 2 good bursts, and after that, you are done. Again, self-rescue only. So how do you fire a fire extinguisher? Number one, we use what's called the pass method. In the pass method, when you have the fire extinguisher picked up, you will pull the pin. You'll aim the fire extinguisher hose at the base of the fire. Don't try to blow it just into the fire, but at the base of the fire. Squeeze the lever and sweep side to side with the hose at the base of the fire, moving forward towards the base of the fire and working on putting it out. All right, fire extinguisher use. Keep the extinguisher pointed at the base of the fire. Never fire the fire extinguisher until it appears to have gone out. Past that point, you're done. There's nothing else you have to fight. You never turn your back on a fire. It's like a wild animal. It will get you. So there's a possibility that if you turn your back, you will not know that the fire has not been dissolved in a way that you can escape. And there's a real problem. All right, so let's switch over to controlling energy. Lockout, tagout. All right. What does lockout, tagout mean? You know, when you have pieces of equipment, they have to periodically be maintenanced, cleaned, repaired. And what lockout, tagout does is it essentially makes it to where there's no energy source going to that piece of equipment at that time. And what we do is we use a device that isolates the energy from that equipment being actually put into position. And these energy isolating devices are lockouts. That's what we call the lockout portion of lockout, tagout. Lockout is any action of attaching a device to a machine or piece of equipment to make sure that the machine remains inoperable when not in use or when repairs or adjustments are being made. It's important to know that these energy isolating devices, they stop the energy, but it's our responsibility to make sure that we check that all the energy has been removed before we attempt to start working on this piece of equipment. A tag is similar to a lockout. That the situation where you put the tag on a piece of equipment so that it's notifying people and giving notice that it is inoperable. Which is more safe to use, the lockout or the tagout? Well, if you're using a lockout, the only person who has the key is the guy who put the lock on. So it's pretty solid that it's not going to get turned back on and somebody get injured. With the tagout, unfortunately, it's just a piece of paper on a little wire or a zip tie, and it can be ripped off and pulled away, and somebody could accidentally or not knowingly energize a piece of equipment that somebody's in, and people can get hurt. LOTO, lockout, tagout, is when both are used. As you can see on this situation, we've got a lock and a tag on the piece of equipment. Lockout, tagout is required during any servicing and maintenance of the machines, and when the unexpected startup of the machine or equipment or release of stored energy could harm the workers. So anytime that we're going to do something to that machine outside of normal function of the process is intended to use for, we must use a lockout, tagout system. All locks and tags and chains and fixtures must be supplied free of charge by the company. We don't require you to go out and get your own. If you're going to be in a lockout, tagout situation, we will provide you with the appropriate pieces of equipment. All right, when any lockout, tagout is undertaken, the program must identify 3 levels of people within that situation: the authorized worker, the affected worker, and the other worker. The authorized worker locks the tags on the machines or equipment to perform the maintenance. He's the guy that's the most trained. He's the guy that has all the knowledge to identify those hazards, and that's why he's in that position. The affected worker is somebody who might use that machine that's being locked out. He does not perform the lockout or the maintenance, but he is affected because the equipment is locked out. Other workers may be in the area of the lockout, tagout is happening, and should be informed that this piece of equipment is locked out and that they could come into contact with something that's not just a failure of the system, but it's actually intentionally been removed from the service. Before lockout, tagout devices are applied, all affected workers have to be told. You have to let everybody know, hey, we're going to lock this piece of equipment out. That could be done by posting signs. A lot of people have the little teepee signs they put in the area so that the people can see we have a lockout, tagout situation going on at this time. And OSHA actually requires, for when you're going to do a lockout, tagout, that you follow the 6-step procedure. Initially, you prepare for shutdown. All right, that's so that you're going to let everybody know, hey, this is what we're going to do. Piece of equipment A, this big table saw, we're going to lock this thing out so that we can do maintenance, repair, and change the blades. Secondarily, after everybody's been notified, you shut down the equipment, and then you isolate the power source. And once you've isolated the power source, then you apply your lockout, tag out devices so that they're in place. You release all the stored energy, which implies waiting. It doesn't mean you turn off the machine and put a lock on it so they can't turn it back on. That's not lockout tagout. That's turning off a machine. There is still power coming to that machine to where if the system fails and electricity bypasses that ignition source, that ignition switch or the shutoff, that machine could still be energized, come on, or there could be the potential for electric shock for the guy working on that machine. The lockout tagout means you've completely removed that energy source. That may be unplugging the machine from the wall and putting a device over the plug-in so that the machine couldn't be hooked up to an extension cord or somewhere else and be re-energized. And then the final step to the process as required by OSHA is confirmation that energy has been isolated. In other words, you ensure that machine is down. You ensure that machine cannot re-energize and come back on, injuring somebody in the process of doing maintenance. Remember, the locks and tags alone do not control energy. Energy isolating equipment from the energy source means de-energizing completely. You have to ensure that the energy is away from the piece of equipment. This is a group lockout box. This is where we can have multiple people working on the same area. We have one guy in control who controls the box lock, and then everybody else puts their own lock on there. On this one, you can see there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 people could be doing their own version of lockout. This is a great system. Unfortunately, people get frustrated because I get done with my job and I need to take my lock off and I need to test what I've done to see if I've done it right, and 3 other guys have still got their locks on there. That means I can't go any further. There may be a little more time involved. There may be a little more process of waiting, but it ensures that a bunch of people don't get hurt. This replaced the people waiting and trying to catch the right time to put their own lock on an individual piece of equipment. These lockout boxes are excellent for the group lockout. You have one person is designated to control all of the energy source locks. The authorized person places their lock and puts the key in the lockbox, and the authorized worker attaches their own lock to the lockbox, and it's equal protection for every worker involved. It's a great situation. The lockout lockbox, the group lockbox, is excellent. If you're working in an area where there's simultaneous operations going on, you remember from our previous, the SimOps, we need to know that they are all locked out and everybody is equally protected. The main locks on the equipment cannot be removed until all locks have been removed from the lock box, and that means the guy in charge of the box has the last and final say, and he clears the area by unlocking his lock. When lockout devices are removed, all affected workers must be notified that the lockout devices have been removed. We don't want people thinking that something's been locked out and is going to stay locked out. We have to be prepared to let everybody know that this situation has been resolved. All right, let's move into electrical safety. Workers are divided in 2 categories when it comes to electricity. You're qualified and you're unqualified. A qualified person is somebody who's been trained. They know how to identify hazards as related to electricity and their components. And the unqualified person has little or no training in electrical work. That might be a helper. That might be somebody that's just working with that electrician for the day. I don't want to use the word electrician. That's actually a craft. But it's somebody who's untrained, who's responding to the actual person supervising them. This course does not qualify you to work on any kind of energized parts. This is an awareness of electrical work. Don't by any means think that you can go from here and climb a pole and start working on electrical wires or rewire your house. That's not what the intent of this course is. And as you see here, as we've said before, you only respond to the level of training. If you're not a qualified electrician, you should not repair any work or any electrical equipment. Unsafe work practices as it relates to electricity. Failure to use proper lockout tagout. We just talked about, if you're in there doing maintenance on a piece of equipment and the thing has got energy still to it, man, you're in a lot of danger. Unauthorized work on energized circuits. You see these electricians who've done this stuff for years and years and years, and you ask, hey, you me turn the power off at the box? No, I got this. It's just a little outlet. Well, a little outlet can kill you, and that's proof in history. A lot of men have died doing small projects at home, not knowing that they could get grabbed by a faulty circuit. Not using your PPE as required for the job, and putting materials too close to an energized circuit and actually catching an arc that electricity trying to get to ground jumps from the circuit to you through your tool. Unsafe work practices includes poor working conditions, working positions, reaching in or near energized circuits where that arc could happen, and not using a ground fault circuit interrupter near any kind of water source. Unsafe work practices have unwelcome results, including all of these listed here. These are minor. People don't take into consideration the lasting effects of getting shocked by electricity. Number one, after you've been shocked, depending on the severity of the shock, it could have actually done some damage to your heart. Your heart being an electrical motor, if you have the right amount of electricity going through it, you could have actually done damage. When you get burned, you can have tunneling. If the electricity is trying to get to ground and you become that conductor, say you touched it with your hand and it blows out the back of your ankle, it didn't go on the outside of your body to get from your hand to your ankle. It went through your body, and now you have this seared tunnel going through your body. So everywhere that seared electric bolt went through your body has to be cut out and revised. It's kind of a dangerous situation. All right, energized and de-energized are two statuses given to electrical equipment. A lot of people get this confused. So an energized is a closed circuit and a de-energized is an open circuit. This is the way I explain it. If you remember the old Frankenstein movies, when the guy Frankenstein is getting ready to bring his monster to life, he's got Frankenstein on the table and he runs over to the wall and grabs that big electrical arm and slams it into the lock position, and you see electricity go crazy and the monster comes alive. Basically, before he slammed that arm up into that circuit, it was open. So electricity couldn't get from one side to the other side, completing the circuit. When he closed that arm into that circuit, he basically made a full contact run from one side to the other side using that arm, and now everything was connected, and that closed circuit allows electricity to flow through it. So an energized circuit is a closed circuit. In other words, there's a full path of electrical conduit, whereas a de-energized circuit is open. There are breaks in the pathway and electricity can't move through them. Exposed de-energized and exposed energized electrical equipment. Equipment must be completely de-energized and free from stored energy before you start work. That is, before you start work. Unqualified workers should never work on any circuit parts that have not been completely de-energized and been basically supervised by the qualified individual. Hazards of working near energized equipment, man, this is a minimal list. Sparks, fires, you can be shocked, you can get dead, and the unfortunate side of it is if you're there and you're shocked, in emergency services, we can't even get to you until we de-energize the circuit, and that's a problem of you just laying there being burned alive, or even worse, just being blown apart, and it's a bad situation. Don't take the risk. If you have energized circuits, don't be involved with them. Portable equipment. Minor sparks can ignite gases. A lot of people use these portable hand tools when they come to the areas, not realizing that their environment is hazardous based on the location. So if you're going to work in hazardous situations, make sure your equipment, your portable tools, are intrinsically safe. Never use equipment that's been broken or misused or faulty in any way before you use a piece of equipment. Like any other safety device, you're going to inspect it, and if it's broken, don't use it. Don't have that I do it all the time in my garage mentality. If you want to do it in your garage, that's up to you. But if you come to the work site, we only use approved equipment that is electrically sound and not damaged condition. Extension cords, man, this is my pet peeve, and it's low-hanging fruit for OSHA inspectors. Your extension cords have got to be inspected. They've got to be in good working order. They cannot be light or medium duty if to be on a work site. You never use them as a rope to haul equipment up on top of the ladder. You never tie your toolbox shut with them. You make sure before you plug them in that they fit the receptacle. There's just no reason to be shocked with an extension cord if you just take a little bit of time to look at what needs to be done. Do not lay electrical and extension cords or cables on floors or walkways. They become trip hazards. They become areas of slips and falls. If you have to put an extension cord across a walkway, then you need to put some device there that identifies it, number one, and that secures it to the ground so that people will not trip on it. Double insulated tools protect workers from electricity. The double insulated tool means that they've actually enclosed or encased the wire source or the electrical source in such a way that there's not exposure to any metal parts or to the employee. You see that little symbol, that double square there, that little picture on the right hand side? That means that that has been double insulated and that the insulation barriers so no exposed parts can get to the employee. All right, overhead line safety. Man, this is a big thing when we talk about cranes and forklifts and people coming too close to these lines. What a lot of people don't realize is electricity wants to get to ground. And if you put something close to that line, it will arc to get to ground, because right now that electricity is traveling through that line. Let's just say it's going horizontally with the ground, but its ultimate goal is to get to ground. So if you become that part near that wire that it can arc to get to ground, it will. So that you cannot be around anywhere where that you can become the ground for that electricity traveling. When an unqualified worker is working in an elevated position near overhead lines, the worker and the longest conductive object they may cannot contact. Man, I can't talk today. The worker and the longest conductive object they may contact cannot be closer than the OSHA mandated minimum approach distance. And here's the distance. If it's 50 kV or below, your minimum approach distance is 10 feet. That's it. If it's over 50 kV, it's 10 foot plus 4 inches for every additional 10 feet. If it's unknown, you don't know how much electricity is going through that line, it's 20 feet. So unless you're working for the electrical company, you most likely don't know what that kV is. So you should always use the 20-foot rule and don't get any closer than 20 feet to a line you don't know about. This character right here, let's look at that picture for a second and let's see what's going wrong with this guy's work habit. Well, he's got his hard hat on, that's good. No other PPE. He's in a big metal box and he's slapping a power line with a shovel. Let's see how that works out for him. That's about right. All right, safety related practices used to prevent electrical shock. Use grounding guarding. Use GFCIs, the fault circuit interrupters, if you're working near water. Conduct inspections. Man, follow your grounding programs. If you're not trained to touch electrical work, don't do it. If you see somebody in a position of authority that's doing sloppy work and taking risks, stop work authority comes in, you stop the work and you get it fixed. Circuit breakers or fuses designed to protect equipment, not workers. People confuse that thinking, oh, it's got a fuse, I won't get shocked. That's not true. The fuse is designed to burn out so that the equipment doesn't burn up and cost a lot of money and further cause problems. But you could still be shocked if the failure of that system goes through to that piece of equipment. A GFCI is there to protect the worker. That actually stops electricity to protect it from getting to you. There's an extension cord that would probably cost you in the neighborhood of about 13 grand if OSHA were to see it on a location. The other side of it is, man, you're just taking an unnecessary risk. If you've got that piece of equipment on location, get it to an area where you can cut it up. The safety guy can cut the ends off of it and get it off your location so that there's not a problem. Wrapping black tape around that only increases the chance of hazards because people have a false sense of security that that's been taken care of. It doesn't fix the problem. This piece of equipment needs to be removed from the location. Electrical protective equipment must be appropriate for the specific parts of the body they need and protected for the work that's being performed. If you notice, this guy is wearing 2 pairs of gloves. Interesting. Is that what he needs for this piece of equipment? Well, apparently, for what he's doing, there's a heat risk as well as an isolation risk. One of those pairs of gloves looks to be a rubber glove so that the electricity won't travel through him. He's got a face shield on with a drop-down hood underneath it to protect the side from any arc blast that might come across. He's really doing what he needs to do to work in that equipment. There are many types of PPE, and they need to be specific for what you are doing. If you're not using the right PPE, literally you're just putting on clothing that's not needed because it won't help you anyway. All right, confined space entry. Confined space is any area that's large enough for the worker to get into. Its entry and exit points are very limited. In other words, you got an open hatch to come in and out of. That's it. and it's not meant for continuous human occupancy. I had a teacher one time that identified a car as a confined space because it was large enough to get into, and it's not meant for continuous human occupancy, and there's only 2 doors to get in and get out of. Well, that's not true. A car is not a confined space. A car is meant for human occupancy. That's why we travel in them for hours at a time. A confined space that we see that we're talking about in industry would be something like these tanks or vessels or silos or any open surface that's greater than 4 feet. That would be something we would consider a confined space. There are 2 types of confined space: permit and non-permit required. Non-permit required do not have the potential to contain hazards that are capable of causing death or serious injury. If you're in a excavation that's 4 feet deep but 16 feet wide, your engulfment risk is almost 0, but it's still a confined space. Now, that's different when you're dealing with permit required confined space. A permit required confined space has all the requisites of a confined space with the addition of a recognized hazard. It could be engulfment. It could be a deficient oxygen environment. It could be some substance in there that can create an atmospheric hazard. So if we have a permit required confined space, there's a totally different animal here. Before you begin work, you have to do a permit. The permits must be completed and given to a supervisor to approve. They must be company specific, and each facility permits may be different. All workers involved in a permit confined space entry must be appropriately trained. You can't just be, hey, we're going to go in and clean this tank, just follow the other guy, you'll be fine. No, you got to have properly training. Your company must train you to be working in a permit required confined space. OSHA identifies that there are 4 levels of training to go into a permit required confined space. You have an entrant, an attendant, an entry supervisor, and a rescuer. The problem with confined space rescuers is people don't actually get the appropriate training, and we find that most people that die in confined spaces were untrained rescuers. If you're going to be a rescuer, by all means, go get trained up and be a rescuer. But just because you can see the guy and you can hold your breath and jump down in the tank doesn't mean you're a rescuer. That usually gets you dead as well. Here are some atmospheric hazards. It's known as being oxygen deficient if there's less than 19.5% oxygen in the tank or wherever confined space you're going into. Oxygen enrichment, anything more than 23.5% oxygen is considered oxygen enriched. That's dangerous because it can be an ignition source or a fire fuel source for a fire. Any flammable gas or vapor, combustible dust, toxic gases and vapors and fumes that could displace the oxygen, all these must be monitored continuously while you're in the confined space, before you go into the confined space, and while all work is being done in the confined space. Other hazards I mentioned before: engulfment. If you're in a trench, it can be engulfed. If you're in an area where the oxygen's deficient because there's chemicals in the area. I actually worked a case one time where 2 brothers died. They were inside of a tanker truck, the tank portion of a big 18-wheeler that had been carrying some solvent, some paint solvent, and their job was to go in there and spray wash out these pieces of equipment, and they died from the environment inside there because oxygen was deficient. Other hazards could be falling from heights, electricity, drowning, temperatures, high noise levels. There's no way to get away from it in confined space, and vibration that over time diminishes your ability to determine if you're in trouble, as well as does damage to your equipment. Workers must not attempt to perform a confined space rescue unless they've been properly trained. I can tell you as a paramedic, going into an area for a confined space rescue and picking up a person is not as easy as it sounds. You got the average guy weighing about 180 pounds. If you've never tried to pick up dead weight, and I don't mean that the guy's dead, but pick up weight that doesn't help you, that has arms and legs that flop back and forth, all the joints that bend and move, not to mention that he's probably going to be covered in some kind of dirt or slime to go along with it. It's extremely hard. And imagine if we're in a tank and we have to lift this guy out. There is no pressing 180 pounds over your head while wearing all your safety equipment and doing it safely. It's just not going to happen. So training in these IDLH environments, or immediately dangerous to life and health environments, must be done appropriately and must be in a situation where people know how to use the appropriate equipment to do rescue. All right, tank gauging. Tank gauging. Tank gauge is when workers manually go out into tank fields or tank batteries to determine how much fluid is in the bottom of that tank and how much more needs to be allowed before it needs to be emptied or whatever the process is. These tanks near production sites are under pressure of the gases and vapors that are collected inside of them. And when the tank gauger pops the hatch at the top, he may be sitting in a cloud of poisonous environment gases that come out and just engulf him. Tank gauging can expose workers to release of these pressurized hydrocarbons and gases. The area becomes immediately oxygen deficient, and the potential for fire is extremely high. Workers should follow the operator company operating procedures before entering these conditions. If you don't know how to tank gauge and somebody tries to send you up to do it, you emphatically tell them no. Gauging a tank is a skill that requires training. You need to be mentored, and you need to understand that when you pop that hatch, number one, it's going to be under pressure, so it could jump back at you. If you're in the way, you could be struck by the hatch. The other thing is, any gases that are under that tank are going to come out immediately. It's not going to be even a slow process. You're going to get from fresh air to engulfed in seconds. So there are acute exposures to hydrocarbons and gases that can affect your eyes and lungs, and CNS stands for your central nervous system. If the proper concentration of those gases hits you, you could die suddenly at the top of a tank. If not, you could be rendered unconscious and roll off the top of a tank and enjoy a 30-foot fall onto the ground and whatever's lying around down there. So if you're going to be tank gauging, you've got to be prepared and properly trained. Even brief exposures, they can kill you. Even if they don't kill you, they'll make you sick for some time. So you have to be potentially trained. Potential for exposures during tank gauging can increase because of produced fluids and reservoir characteristics. Basically, what are we putting into that tank and how long has it been sitting there? How hot has it been? How cold has it been? All these factors must be considered before we pop a tank's gauge. Controls, they have controls that we can put in place. You can have these special valves that are like a collar underneath the hatch that will release the pressure. They're like a pop-off valve on the top of a hot water heater, and then you can know as you're going up on the tank to gauge it whether you're entering into an environment that's dangerous or not. All the tanks should be grounded because there is flash fire potential if you have something that can create a spark. Workers with tank gauging have to be trained. They've got to know how to recognize the hazard, how to use the equipment like a multi-gas detector, and they've got to know the company policies emphatically. Not just know that we have policies, but know where they are, know how to use them, know what PPE that they are required to use, if they're required to wear an SCBA to bring air with them, the limitations of that SCBA, how much time they can expect it to last. All these things have to be part of their daily routine, basically muscle memory. All right, so that ends section 3, and we're going to take a short break, and after that we will move into our next section, section 4, module 4.